Hello, everybody. Good afternoon. It's really great to have you here. Welcome to another Oxford Sparks live Q&A. We're doing these every week during lockdown, and they are live. So this is a great chance to be able to ask all of those questions that you would like to ask our scientists here at Oxford. If you're new here, then please do consider subscribing. That way you'll be the first to know about all of our new videos, animations, and live events like this. And yeah, I think we'll get on with it. So I'm delighted to be joined today by Professor Tamsin Mather, who is from the Earth Sciences Department and is a volcanologist. So welcome, Tam.
Hello.
It's great to have you joining us here this afternoon, and I can see from the chat box that we've already had questions in, which is amazing. So as I say, this is live. Please do keep those questions coming, and over the next half an hour or so, we will try to answer as many as possible. What I'd really like to start off, though, by doing is just asking you, Tamsin, if you could introduce yourself and telling us a little bit about your research in a couple of minutes.
Okay, yeah. So I work in Oxford in the Department of Earth Sciences, and I work on volcanoes. And I guess I'm fascinated by volcanoes for kind of three main issues. The first is maybe the most obvious in that they're hazards. They're natural hazards on a very human scale, and they can impact lives and livelihoods. So we're very fortunate in this country. We live in a relative tectonic backwater, but volcanic hazards have reached out and touched us with things like the 2010 Arafat-Yerkut airspace closure, which I know in these days of lockdown seems a little bit distant and kind of almost new normal. But there we go. It was quite a shock to us all at the time.
It was, yes.
And then I guess the area I actually worked on for my PhD is a little bit different. I was thinking about volcanoes and their effect on the environment. And their effect on the environment, like close to the volcano, far away from the volcano, and actually also over long time periods, and for very big eruptions on the like planet-wide scale as well. So volcanoes can have a really big impact on our environment, and they've been a really key part of one of the key processes that have kind of driven both change but also continuity in terms of the way that our planet has evolved, and why our planet is how it is, whereas Mars is a very, very cold place and Venus is a very, very hot place, and why we're in this lovely kind of happy medium, which allows us all to kind of flourish on this planet. And I guess the third reason is they're actually also natural resources as well as natural hazards. So to take an example from not that far away from us here is like Iceland gets a really significant amount of its power from geothermal activity. Yeah. And so, they're also a real opportunity. Tourism is another way that the opportunity can be realised. So they've kind of got all these different angles on their personality, if you like, and that's what really fascinates me about them.
Yeah, absolutely. It's so interesting just to hear you talking there, and in a couple of minutes, we've touched on so many different aspects of volcanoes and volcanology that I bet a lot of people haven't thought of when, we just picture this cone shape that you've studied while you're at school, and not all of these different aspects. So what made you decide to study volcanoes? Was this something you've always been interested in, or you became interested in at university maybe?
Well, actually, I came to it quite late in the day, so I'm more of a sort of accidental volcanologist, really. So many of my colleagues really have had a passion for this since very young. One of my colleagues saw his first volcano when he was about 8 years old and was absolutely hooked on them ever since then. And how amazing to be able to say that you are what you wanted to be when you were a child. But actually, I came to it quite late, so I did my undergraduate degree in chemistry. And then I actually left science for a couple of years. And during those couple of years outside science, I sort of did a lot of thinking. And I realized I wanted to go back into doing a scientific PhD if I could. But I wanted to do something that definitely wasn't just in the lab. I wanted to do something on a larger scale. I was happy to do some lab work, but I also wanted to think about how we applied chemistry to the big scale and to big scale phenomena.
Yeah,
and so I applied for a range of PhDs in chemistry of the oceans, chemistry of peats, and environmental archives, all sorts of different stuff. Actually, there were lots of. I looked at specific projects and got interested. I applied to one department, to Cambridge, in fact. And on the form, it was a paper form in those days. It wasn't online. On the form, I had to put a second choice PhD project, and I had this one on the chemistry of oceans, which I was excited about. I looked through the booklet of projects, and I couldn't understand many of the names of some of the titles, even of the projects. They kind of had P waves and S waves, which I hadn't heard of at the time, and plagioclase, which is something obviously I know a lot about now, but I didn't then, having come from chemistry. But then there was this one on the tropospheric chemistry of volcanic plumes, and I'd done atmospheric chemistry as one of my fourth year topics in chemistry. I thought, hey, I recognize all the words in that title, and volcanoes are exciting. I've been and actually visited a friend in La Réunion when the Piton de la Fenesse was erupting, and had been awestruck by it. So I thought, well, that definitely sounds something I could live with putting as my second choice. And then when I went for the interviews, I just got much more captivated by what I could bring to that project rather than, in the end, the ocean chemistry, which was very interesting too. So I asked to swap, and the rest is history, I guess.
Absolutely. That's so great to hear. I think often people imagine there's one particular route into this kind of career, and actually it's not the case at all. And it's really lovely to hear actually that this wasn't necessarily something that you knew from age 5 you were going to do, but actually you came to in this roundabout route. But well, you're obviously very passionate about it, and I, for one, am very glad that you pursued the volcanoes. As I said, we're getting questions in, and just to say, if you see me looking down here, it's because I've got my eye on the chat box, so please do keep those questions coming, and we will get them to Tamsin. So there was one that came in fairly early on, and I thought it might be a really great place to start, actually, before we delve into anything else, which is from Elwyn, and they ask, what are the types of volcanoes, and how do they erupt?
Oh, that's a great question. There's actually a lot of different ways of categorizing, organizing the world's volcanoes, if you like. So one key way is the places that they occur. So when I say places, I mean like tectonic places. So how they relate to the grand scale of the planet and the plate tectonics. So the surface of the planet is split up into these separate plates that move with respect to each other. So they move at about the speed your fingernails grow, if you want to get a kind of sense of sense of the scale of it. And they're moving around. That's part of what causes most of the world's volcanoes. So you've got places where plates are moving apart from each other. So a good example would be the Mid-Atlantic Ridge. So obviously we don't see most of that because it's deep down underneath the ocean. But you see Iceland being a bit where it comes to the surface, and there's something else going on there which brings it up to the surface. But that splitting of the tectonic plates, or the moving apart, it actually changes so you've got the Earth's mantle underneath the crust that is solid but able to creep, this very, very slow creep, the fingernail growth to move. And it drops the pressure because the plate is splitting apart. It's like unloading. It's like sort of taking a load off your shoulders when you take a big backpack off or something. So it drops the pressure on the mantle underneath. And that change of pressure alters the melting point of the rocks in the mantle. So you get melting going on, partial melting going on, because it's a complicated thing, the mantle. And that gives you magma, and that magma finds its way to the surface, and that's where you get mid-ocean ridge volcanism, where two plates are splitting apart. But if two plates are coming together, we have something else going on. So that's your mid-ocean ridges or splitting plates, your first category. When two plates come together, you end up with the more dense plate sinking into the Earth's mantle underneath the less dense plate. So often this plate here is the I do a lot in interpretive dance. This plate here is the continental plate. So to take an example, this could be Chile in South America, and then this is the oceanic plate going underneath it. And when that plate goes down into we call it a subduction zone, it's got a load of other stuff. It's got rock on it, but it's also got a lot of water that's been captured in the structure of that rock, but also in the sediments that are on top of it that have been laid down in the ocean here. And that water goes down and gets heated up and basically released from this down-going plate into the mantle in this area here. It changes the chemical composition of the mantle there. So it's a bit like going out in the winter and sprinkling salt on your driveway because you want to melt the ice. So that water going into the mantle there causes it to melt again. So we get volcanoes there. So we call these subduction zone or arc volcanoes. And that's a good example is the Pacific Ring of Fire. All the volcanoes around the Pacific Rim there, they're arc volcanoes. So those are the first two categories. And then the final one are volcanoes like Hawaii. And if you look at a map of Hawaii, you see it's like a chain of islands. And what we have there is a hot spot, a hotter area inside the mantle underneath the crust, which is causing the mantle to partially melt. And then the crust, the plate is moving over that mantle. And that's why you get this chain of islands. So we've got Kilauea volcano on Hawaii that's active at the moment. But it's that will die eventually. And you've already got a new volcano coming called Lohi that's just off to the east of Big Island, Hawaii right now. So those are the three main reasons we get volcanoes on Earth. And there's some sort of complexities that go, but those are the three main categories.
Volcano types in a nutshell. Brilliant.
Yeah.
That's fantastic. And in fact, we've had a couple of questions in, one from Jake, age 8, and one from Dylan, age 8. And Jake asked how are volcanoes formed. So hopefully that kind of answers your question, Jake. And also, what's the most common place for volcanoes, which is what Dylan asked. And again, we touched on a few places there. So Hawaii, the Ring of Fire, but I don't know, are there any places where volcanoes form which might surprise us? I suppose it's the places where the tectonic plates meet.
Yes, it's mainly where the tectonic plates meet. So most of the world's volcanoes are at the mid-ocean ridges, and then at the subduction zones as well. But there are places that you might not immediately not immediately think of being in one of the categories. So East Africa is a really good example. So I've done quite a lot of work in Ethiopia, and there we actually have a tectonic plate kind of splitting apart. So we're getting something that's like the beginning of a mid-ocean ridge going on in East Africa. So if we were able to kind of real time forward by millions and millions of years, we'd have this sort of splinter, Ethiopia and that strip down like that, basically sort of tearing off and a new strip of ocean forming in that part there, we think.
Oh, fascinating to see the beginnings of something like that. Wow. Great. So maybe now is a good time to ask, actually, if you have a favourite volcano, because we've heard about the different types. And I know you do a lot of field work, which we'll be coming onto as well. And there's been a few questions about that. But is there any one particular that you're particularly fond of?
It's a tricky one because it's not quite as bad as being asked to choose your favorite child, but so I'm not sure I'd like to call it my favorite volcano, but a volcano that always has there's several volcanoes around the world that have very special places in my heart. So another example, a place like Etna and Stromboli in Italy, Masaya volcano in Nicaragua, but I guess the one I normally say is Rica volcano in Chile. And the reason for that is just the first time I went there, which was during my PhD. We arrived and the weather was absolutely terrible. So it's in the Lake District of Chile, which is a little bit similar to the Lake District here in the UK, but you've got these snow-capped volcanoes, and maybe if I get a chance, I can show you a photo in a second. You've got snow-capped, beautiful conical volcanoes, but when we arrived, we couldn't see it. We just had this cloud layer that was blocking out. Everyone was very pessimistic. They were saying this weather system is set in. You've got to be here for 2 weeks. You can't climb the volcano if the weather's that bad. So we were sort of thinking we were just going to be sitting, twiddling our thumbs for 2 weeks, frustrated about the data we weren't getting, having come all that way. And I think it was like that for the first 2 days. We had problems finding accommodation. But then on the second day, we found a cabin on the side of the volcano. And we were invited to a barbecue, which is a different story, by the Chilean hosts in at the cabins. And we arrived on time at the barbecue, being very British, and the Chilean time turned out to be like everyone else arrived about an hour later. But we were just there at the barbecue, had a cold drink in hand, and the clouds had been kind of brightening over the day. And then the clouds just sort of split, and there was this absolutely beautiful kind of picture book, textbook volcano with the gas plume puffing out the top. And I felt like there ought to be kind of people trumpeting and choirs of some sort singing Alleluia or something as the clouds parted. And then we had, actually really lucky, we had a fantastic 2-week weather window, and got lots of great stuff done.
Oh wow, that is very handy for field work. It sounds so great. Memories that will last a long time. And as I say, a lot of people have been asking about field work. Earlier you said you wanted to do something that wasn't just lab work. Is the field work what attracted you to this? And have you got any particularly exciting stories from field work you'd like to share?
Yeah, I mean, so the field work is definitely a really, really interesting part of the job for a lot of different reasons. I mean, it's one of the ways it's not the only way, but it's one of the ways that we get data. And when you go somewhere, you just get to understand it in a very different way. And there are things you learn by being in the field that you can't do from books when it's a sort of when it's a science of a natural phenomenon like this.
Absolutely.
And I mean, I've also always been interested in travel, and so the cultural side of it I find very interesting as well. And I think you get to work with local scientists and local observatory staff, which I find absolutely fascinating. And no one knows their volcanoes like they do. So that's an enormous learning opportunity for me. But that's not, I mean, I think what I really love about this, my subject, is the combination of things. So I do really enjoy lab work. There's a massive buzz, and this can happen in the field as well when you're getting real-time data, but there's a massive buzz from that data coming in and being the first person to look at that data and plot it up and to see that it tells you something. I mean, sometimes it doesn't, and you have to be prepared for that too. But being the first person in the world, however small it is, who kind of knows this first new thing. And I guess quite often now my students get the data in first. They have that kind of moment, that buzz. But every now and again, I do some of my lab work, or I get sent the data from someone, and I often can't resist plotting it up, even if I've got to forward it straight on to a student. And I won't tell them always, but I just like that kind of like, ooh, what does this mean? So I think it's the variety. So the field work is amazing, and it often gets a lot of the attention, but it's also the kind of the things that you can discover from that, and the combination of that with the laboratory work, with careful reading, careful thinking, mathematical modelling sometimes as well.
Yeah, absolutely. It's all those different elements that come together and kind of put the pieces of the puzzle together. So a couple of things. You just mentioned then about your students. So I thought now might be a good time. Somebody had asked if at Oxford Volcanoes are part of the Earth Science degree. Actually, it didn't just specify Oxford. I can't say for other universities, but certainly at Oxford, and Tamsin will be able to confirm, volcanoes are part of the course.
Yes.
Yes.
Yeah, absolutely. So, yeah, no, you do some in the first year, and then there are major options courses in the third and the fourth years at Oxford Earth Sciences.
Brilliant. So yes, if you're keen, I don't know what sort of stage you're at, but please do apply if this is what you're interested in. And there was another question, I think the first one we were asked actually, which was from Johnny, and I wanted to come back to. You were obviously talking about all the different places you've been on fieldwork. Is it normal for a volcanologist to travel around to lots of different sites, or do they tend to specialise on one particular volcano, or is that very much variable depending on the person?
Yes, that's very variable. So some people definitely get very into going to one place, and it might not just be one volcano. So I have colleagues who work a lot in Iceland, which is totally understandable. It's a fantastic place to work,
and it's beautiful.
And there's a lot of interesting questions to ask there. And then some people get very into, can get very into one individual volcano, which is, and particularly if it's very active. Then, and of course, that's what the observatory staff are. That's their job, is to be into a very particular volcano, and they're doing really important science from that point of view as well. So it really does vary a lot.
Yeah, absolutely. No, that makes sense. Did you say you had a couple of photographs you might be able to show us?
Yeah, so Let me see. So you want me to share my screen?
If you share your screen, we should be able to do some technical jiggery pokery and allow the viewers at home to see as well. Still waiting for confirmation. There we go. I think, lovely technology. I think you should be able to see those at home now. So, Tamsin, do you want to chat us through,
Yeah, so
what we're seeing?
This was via Rica. This was the field trip I was just talking about earlier. So this is during my PhD, which was a few years ago now. But so this is the view I was talking about when the clouds parted, and you can see here, the gas plume here, and then this little puff of ash coming out of the crater top here. So I just wanted to talk you through climbing up. So you can see that you climb up an ice cap on the edge of Via Rica. So you sort of actually go up this sort of way and then like that. So this is us climbing up the ice cap here. And you can see it's quite a tourist destination. So you can see that gas plume. It's actually a friend of mine from school had been about 6 months earlier to Via Rica. And she climbed it, and she was absolutely disgusted by how smelly it was. And she told me this when we met up at home for drinks at in Bristol at Christmas. And she was going, oh God, it was disgustingly smelly. And I literally was going, yes, fantastic. It's good and gassy.
That was going to be one of my later questions: is how smelly a volcano?
Right, so. we can talk about that.
Yeah.
You can see that these are the tourist groups. You sort of tramp up in a sort of zigzag pattern like this. And here am I halfway up with the ice axe and what you can see here, I'll also tell you about. This is another fun thing about Via Rica, which people are always quite fun to hear about. Is these are the ice chutes, which is the way you come down the volcano. So I'll show you some photos of that in a minute. So this is me at the top, having so this is a crater, and we couldn't see it at the time, but there's actually a lava lake down in the vent of the crater here. And this is me at the top here, and you can see the sort of ash-covered snow at the top. So I'm feeling a great sense of achievement at this moment, peering into the mouth of the beast, and probably quite out of breath after puffing away up the ice cap.
That's quite hard work.
Yeah, no, it was. I think it took a few hours to climb. This is doing some measurements. So some of the challenges. So we've got a spectrometer here making gas measurements, and then I'm using a bin liner to try and kind of see the computer screen at the top of the volcano. And you can see there's a lot of duct tape and stuff, which always seems to be quite an important part of my field work. All the high-tech bin bags and stuff. This is me in my gas mask. So you can see I think my gas mask broke on this day, which is why I've kind of strapped it together around my face with all the sort of taping there. I'm trying to make some notes in the notebook. It was quite difficult because you're kind of wearing gloves and it's quite breezy at the top of the volcano, so you're trying to write down your notes. Anyway, as I said, this is the way you get down the volcano. So I've got a rucksack here full of samples and equipment and stuff. And then you get into these sort of ice gullies like this, and the only way you can kind of break yourself is using your ice axe and your heels on your shoes. And so you can see me going off down my ice chute. And what you don't see in that photo is actually just shortly after that there was a massive step in the ice, and you just went down, boom, like that.
Oh, wow.
And I ended up with the most enormous bruises on my backside that I have ever had in my life. They're about the size of my hands. They were huge. With all the equipment on my back, it was a bit of a shock.
Looks pretty fun, though.
Somebody else collided with me on the ice chutes. You can see that. And here I am at the bottom looking. I was obviously been quite a lot of fun. And here I am back at the cabin examining the samples after a hard day out the volcano.
Oh, the injuries, which obviously aren't good, that does look great fun. And I can imagine you must feel pretty cool as well when you're at the top of a volcano and, staring down into a lava lake. So, can definitely see why you enjoy fieldwork so much. Obviously, you're wearing that mask there and a lot of other gear. What kind of protective equipment do you need when you're that close to a volcano?
You didn't see there, so the gas mask, obviously there's a lot of nasty gases that can make you, even if you're asthmatic, it can really harm you. I'm lucky enough not to be asthmatic, but even so, it can really make you feel sick and cough, and so it's important to have your gas mask with you. Eye protection as well. There's a lot of fine dust being blown around at the volcano, as well as the acid gases getting in your eyes. And I don't have it on any, but normally I'd be wearing my hard hat, my helmet. So I just noticed I'm not wearing it in any of those photos, but most photos you see of me up on near a crater, because it's always slightly unpredictable. And actually, when we were up at Rica, we did have some really, really light rocks called reticulite, which is just like a very sort of foamy rock falling out on us. But you always want to be kind of very respectful of the fact that it could do something a little bit less expected. So usually I'd be wearing my my hard hat as well. Volcanoes are big mountains as well, so you also want to be wearing all the right protective gear that you would going up a big mountain. So good windproofs, and plenty of warm clothes. So, and if you've got extremes of like sun, so all the normal sort of stuff like sunscreen and sun hats and all the kind of sensible stuff that you would if you were going on a kind of a mountain hike normally.
Yeah, absolutely. As you say, you've got to respect these environments, and really important to have all the protective gear. So lots of things coming in. I'm going to have to ask you to take a look at these questions as well afterwards, and some interesting discussions going on. We're having a few questions in about prediction, which is very fair, because these are obviously massive natural hazards and can cause huge amounts of disruption. So I think it was Johnny asked, do you really need to get a chunk of molten rock to be able to analyze? Does that help you to predict eruptions, or is there another way that you can predict? Is it all about measuring seismic activity?
Yeah, so the rocks that I was having, so often we get rocks to understand what went on in past eruptions is one of the reasons we might want to get them. That's the interest often, is to understand what's going on in the past in order to help predict the future, because if you understand more about what was going on deep inside the volcano in the past, hopefully there's some continuity. There's not always, but you can use that as a starting point. You can try and understand how the plumbing system of the volcano works, if you like. And the kind of crystals in some of those rocks can act as like, they can have little clues hidden inside them in terms of the chemistry of the crystals, about how deep they were within the volcano when they formed, how much gas was dissolved in the volcano as well. And it can also help us to understand the ongoing activity and what's driving like persistent activity as well. But so that's the sort of one component, which is looking at the rocks from a volcano. But often what volcanic observatories are relying much more on will be things like seismic data. So seismic data from volcanoes, they're very, very really sort of much smaller earthquakes than we're used to hearing about if we're thinking of sort of earthquake hazards in and of themselves. But these small earthquakes, changes in the number of the small earthquakes and their location in the volcano can tell you about the magma moving, the rock moving inside the volcano, because they can be associated with the breaking of rock. They can also be associated with the way that gases are flowing through the volcano. So that's one of the key data streams that volcanologists at volcano observatories will use. Also, they'll use things like how much gas is coming out of the volcano, so make measurements of that, how the volcano might be changing shape, and measurements like that, and just pulling all together these different data streams really to try and understand. Like thermal imagery is another way that's sometimes used, and sometimes different techniques have more promise in different situations.
Yeah, I can imagine that. So. Yeah, as you say, all these different techniques coming together. So I've just seen the time and it's 2:30 already. So I guess we should think about wrapping up. If you don't mind, there have been a couple of questions from very young budding volcanologists. So I'd quite like to squeeze them in. Maybe there's a very short answer we can give. So one of them, which is from Shan's 5-year-old, is bumpy or smooth, which I thought might just be a nice chance to talk a little bit about the rock types. And also Elwyn's little brother, I think, who is 4, wants to know, where does the lava come from, and is it the same as fire?
Okay. So I'll take that one first. So actually, that's an interesting one. No, it's not the same as fire. Sometimes things get burnt but if you get hot lava, which is like about 1,000 degrees, so a lot hotter than your cooker, if that like kind of runs over a tree, the tree will burn. So you can get flames associated if you've got like gases coming out of the volcano are flammable, then they can burn as well. But actually it's glowing because it's hot, not because the hot is not because of a burning reaction. The hot is because the inside of the earth is hot. Hot, and this stuff has come up from inside the earth. But it's actually a really interesting question, because there was a historical debate about what the source of the heat of volcanoes were. So he's asking questions that people have asked before you, but now we know a bit more about, so I can give you that answer. And the other one was, are volcanoes bumpy or smooth? Well, volcanoes can be all sorts of different things. So I guess often they're mountains because they build themselves up with sort of different layers of eruptions or lava. But actually, an interesting one is whether a lava flow is bumpy or smooth. So we've got different types of lava flows, and they have great names, which is why I kind of want to bring them up. I think we use Hawaiian names, and there are several types, but two of the main types are A'a and Poihoe.
They're great names.
Yeah, they are. And I think A'a is like rubbly lava, and Poihoe is like this ropey, smoother type of lava. And I'm not sure if this is true, but someone told me I should check it. That Poihoe roughly means lava you can walk on with bare feet, and must be like because it hurts your feet. I think that
I hope that's true.
Yeah, I hope it's true as well. It could just be an urban myth.
Oh, that's fantastic, and just shows why, however old you are, do ask things, because there are no silly questions, and I've certainly learned something there, so that's fantastic. Thank you. We just obviously talked about those Hawaiian names. Jeffrey Brown was wondering what your take is on the deep earthquakes beneath Pahala in Hawaii. I don't know if this is something you know about, but I just thought I must ask it, because he has a nice volcano in his picture as well.
There's lots of interesting things going. I mean, Hawaii is going through a really, really interesting time right now in terms of its activity. It's been extremely active since the 1980s, and then it went into this really, really the Lower East Rift Zone got a lot of coverage. This eruption in 2018, where it started erupting in a different place from where it usually erupts, and unfortunately it was where people were living, so no lives were lost, but property was damaged, and the roads were cut off, and people had to move, and actually the air quality on the island was really impacted as well. And then that shut off, and at the end of the summer of 2018, and actually it's been much, much quieter than it has for decades since. So we're in this really, really interesting period in Hawaii.
Very interesting.
We're all intrigued to find out what happens next. And Hawaii is a volcano. Kilauea is a volcano that's it's lots of reasons it's very special. One of the reasons it's very special for me is actually Kilauea erupted on the day my daughter was born. So we always tell her it's her volcano.
But she's not called. I think it's okay. Sometimes it.
Okay.
Apologies if we just lost connection. If you didn't hear the last thing I said, I was just asking Tamsin if she has any tips for any budding volcanologists out there. So apologies for that. Technology is.
Well, as I say, I kind of came to it slightly accidentally and late, so I don't know that. I don't know that I am. I mean, there is I guess there's kind of a linear route, but there's also just follow what interests you. Volcanology is a science, and so definitely keeping on with your science and maths at school, and then taking a science-based course at university. So most volcanologists do come in via the science route, some through physical geography, for example.
Yeah.
But keep, I mean, in terms of kind of studying science in general, just you keep interested and find things that interest you, and see where that takes you. See what adventures you end up on. Never stop wondering.
Be curious and interested, and that's really great advice. And like I said at the start, actually, I think it's quite nice to hear that there isn't just this one linear route. And
I think, I mean, I suppose, there's a lot of the things aren't there. It's not always a matter of you need to decide what you want to be when you're 15, or things can take you in different directions, and just try and keep interest you, I guess.
Oh, absolutely. I never knew what to do, and just do what interests you at the time. That's kind of what I think. Brilliant. That's fantastic. I've had a question from Fiona Burgess, who asks if this will be available afterwards as well, and it will be. So please do share this with your friends, family, teachers. And I think we'll wrap up for now. I'm sure we could talk all afternoon about volcanoes, but this has been fantastic. So thank you again so much for joining us, Tamsin. And if you've enjoyed this, then please do join us next week for our next live Q&A. We're actually going to be staying in the earth sciences field, and we're going to be talking to Benjamin Fernando about his research, which is all about seismic activity, earthquakes, not just earthquakes, Mars quakes as well, which you might not even know was a thing. So that's really exciting. That will be next Tuesday at 4:30 p.m. So pop that in your diary. And if you don't already follow us on Facebook, Twitter and Instagram, then please do. It would be great to have you follow us, and that way you'll be the first to hear about new things that we have coming up, including that live Q&A next week. I think that's all. So thanks very much. From Tamsin and myself, and take care, and we'll see you all next week.